So now that you're all experts at pottery reading and you know what ancient coins look like, now let's take a moment to look at stratification and what strata actually look like. What you're looking at in this slide are several strata, and you can see the distinctions on this one section. Down at the very bottom, you can see the bottom foot or so of this picture, we have dark gray, almost black ash. This is a burn layer. There was a destruction that took place here. On top of that layer, you can see about half a meter of red, crumbly dirt with some rocks in it. That red, crumbly dirt with some rocks in it is mud brick. There was a mud brick structure here that apparently collapsed, and so that formed a separate stratum. On top of that, we see about a foot thick of rocky gray debris with some ash in it. So we have another stratum above that, and then above that we have sort of light brown dirt with some rocks in it. So what we're looking at here is 1, 2, 3, 4 different strata in this one section. And this is the typical kind of thing we see when we look at stratification. So we talked about relative dating. Older stuff is lower. Younger stuff is higher in the stratification of the tell. And we've talked a little bit about absolute dating, namely using pottery to establish dates and also coins and the relationship between pottery and coins. Ideally, we find a coin in a pot. That's really nice when that happens. Of course, it doesn't happen all that often, but when you find a coin in a pot, then you get a very precise date for that pot, which then helps date other pots of a similar sort, etc. And that does happen on occasion. There's one other type of absolute dating I'd like to talk about, and that is carbon-14 dating. A lot of silly things are said about carbon-14 dating, so let me clear the air a bit. Carbon-14 is a form of dating that is very useful under certain circumstances and not so much under others. Carbon-14 is a radioactive isotope of carbon that is ingested by living things. So whenever anything's been alive, whether it's a plant or an animal, and then it dies, if you have a large enough sample, you can at least theoretically measure the relationship between carbon-14, which is radioactive and therefore decays, and carbon-12, which doesn't decay. The relationship between those two then, as carbon-14 decays, you should be able to, from the known rate of radioactive decay, calculate backward to whenever it was that the creature died. So carbon-14 dating can be done on carbonized wood, for example. It can be done on sometimes some grain that was discovered that had been burnt or something. Or it can be done on bones. So carbon-14 dating can be helpful for those kinds of things, but it's only for living things. So for example, Stonehenge in England, the holes that support the stones that make up Stonehenge were dug initially with deer antlers. Because the people dug with the deer antlers splintered in the hole, and we have bits and pieces of deer antler down there. Archaeologists have pulled out some of those splinters of deer antlers and done carbon-14 dating, and that gives you a date at what point before the present that those deer died. That's the idea of carbon-14 dating. Now, the theory is better than the practice. In practice, there are lots of things that can distort your ability to either read the relationship between carbon-14 and carbon-12. Your sample size matters. Soil chemistry, where the thing was buried, can change the rate of decay, exposure to sunlight. There's a lot of factors that can affect carbon-14 dating. But what you do is, good archaeologists are very careful. You take multiple samples. You send those samples to multiple labs, and you get multiple dates, and you do statistical analysis on them to try to figure out where things stand. We all know that there's a margin for error in carbon-14 dating. So for example, in Hawaiian archaeology, carbon-14 dating is really important because, for one thing, most of the things we find are not very old. And so the margin for error isn't very great. The margin for error gets greater and greater the farther back we go. In Israel, if we're dealing with something that's about the time of Jesus, something that's about 2,000 years old, the margin for error with carbon-14 dating can be plus or minus 100, 150 years. That can be helpful. It can give us, if that's the best we can do, that's great, but it's not all that precise. And if we go back farther to 1000 BC, 2000 BC, our margin for error with carbon-14 starts to get very large, so large that it stops being useful after a while. So carbon-14 dating is useful for things that are more recent and less useful as we go farther back. We get better dates if we have more samples, bigger samples, and of course we try to send them to multiple labs so we eliminate the variable of any lab issues, the sensitivity of the equipment and so on. The result is, oh, by the way, carbon-14 date, one date costs about $300. So it's expensive. So for the most part, when we do archaeology, we do not do carbon-14 dating. We only do carbon-14 dating when we want to double check something or when we don't have other evidence. So for example, we wanted to get a date for a landslide in the Jordan River. We had evidence of a big landslide. We wanted to know when the landslide happened and buried an animal. We got the bones from the animal, did carbon-14 dating. At least we get within 100, 150 years on the date of the landslide. That's good. That's the best we're going to get. But when we have an archaeological site where we've got stratification and we've got pottery and we've got coins, carbon-14 dating is useless because it's always going to be less accurate than what we can get from the pottery and the coins. So the result is that we use it when we need to. We use it when it's wise. A lot of times we simply don't use it. But I should add, if you're doing Hawaiian archaeology and it's much more recent and you don't have great typology to work with in some cases, then carbon-14 dating can be a lot more useful. And it's the only way, for example, that people are able to make arguments about when did the first humans make it to Hawaii. The only way you can tell is from carbon-14 dating because they like to munch on seashells and they left the seashells in the sand dunes and you can date the seashells. That's about the best we can do in terms of that. And so carbon-14 is great in that respect. Here are some things that you can do carbon-14 dating on. So here we have some skulls, some bones that we found in the Cave of Letters in Israel. We have some strings from a basket that was found in the Cave of Letters. And the archaeologist to the right is actually picking up some ancient goat poop. And so we were actually able to do carbon-14 dating on ancient goat poop. So a lot of things that you can do, basically anything that's organic matter that was once alive. Now the big question. Archaeology and writing. How do we relate the two to one another? There's a lot of silly things said about this. Sometimes you'll hear that archaeology contradicts the Bible. Sometimes you'll hear that archaeology proves the Bible true. Both of these statements are false. Archaeology cannot contradict a written source. It doesn't have that capability. Archaeology can, however, challenge interpretations, traditional interpretations of a written source. It is important to understand that only about 10% of what can be excavated has been excavated in Israel, and Israel, of all places, is the most excavated country in the world. So the result is that there's a lot we simply don't know from archaeology, and a lot of what we find in archaeology does not speak directly to anything that's written, and a lot of what we see in a written text, whether it's the Bible or Homer or anything else, does not directly relate necessarily to something that we find in the ground. But what they do often is speak to one another. The word I like to use is illuminate. That is, they shed light on one another. The Bible can help us find where people lived in a particular site. It can tell us a lot of things about what happened there, and it can shed light on what we're finding in the ground. So when the Bible talks about Joshua burning the city of Hatzor, and we go to Hatzor and we find a burn layer, we think, oh, there might be a relationship between these two. Let's check it out. They're shedding light on one another. Archaeology can shed light on the Bible. It can help us understand things, and the Bible can shed light on archaeology. In my opinion, the best practice is that we ought to be serious students of both and utilize them both to help us understand things. And I should add one other element, that archaeology very often can corroborate a particular statement in a written text. And so if, for example, if the Bible says that King David built a palace, and just recently an archaeologist has found what she thinks is the palace of King David, if all the pieces fit together, we will see. Ultimately, we might be able to say, archaeology has confirmed that particular statement in the Bible. The Bible says that Hezekiah dug a water tunnel in Jerusalem. We discovered the water tunnel. Therefore, archaeology has corroborated that particular statement in the Bible. But everything is very particular. We have to look at them on a case-by-case basis and try to be as honest as we can. If God is the God of all truth, then God's truth is going to be manifest in archaeology as well as in the Bible, and we ought to use both to our best benefit.